What is up, Mathverse? This is Cedie, and welcome to Cedie's Mathverse. So for today's video, I'll be tackling Modular Division, the basics. Happy Easter Day, and without further ado, let's get started. Modular division. When we normally divide two numbers, we usually get its quotient. For instance, when we divide the number 47 by 8, we get 5 as a quotient and 7 as a remainder. But as we approach the higher years of education, we use decimals to represent the remaining portion. We get 5 and 7 over 8 or 5.875. In the process of modular division, the quotient is not needed, but the remainder. So, how does modular division work? Let us find out and discuss these things one by one. So here is a modular congruence statement. So, it shows that A is congruent to N modulo K. So, a modular congruence statement has 5 parts. The first part being the dividend. The second part being the divisor. It's just like the normal division process. The third part is, of course, the desired outcome, remainder. And the last two parts are the modular indicators. So we have the modular congruence symbol, and the shorthand term for modulo, which is mod. So, to pronounce this statement, it goes as follows. A is congruent to N modulo K. So, how does this apply in whole numbers or integers? For instance, we have the given earlier, 47 divided by 8. It is equal to 5.875 or 5 remainder 7. Okay. So we have the dividend, 47, then the divisor, 8. We do not need the quotient anymore. And what we need is the remainder to complete the statement. So we have 47, the dividend, is congruent to, we'll just copy this triple horizontal line, then 7, the mod, and then 8, which is the divisor. So, in this statement, we can show that 47 is congruent to seven modulo 8. Now, let us express some division problems into modular form or modulo form. Let us start with number 1, 112 divided by 15. By using normal division, we have 112 by 15. We have the largest possible value, 105. And we divide 105 by 15, we get 7. 112 minus 105 equals 7, which is the remainder. We now have the dividend, the divisor, and the remainder. So we can now express this as 112 is congruent to the remainder 7, open parenthesis, mod 15. So here's the first statement. The second statement, 2020 divided by 11. Let us do normal division again. 2020 by 11. If you can do it mentally, much better. 20, the largest possible, will be 11. In this case, we won't care about the quotient anymore. What we need here is remainder, so I won't put the 1 above this division process. So 20 minus 11 is 9. Let's bring down to 92. Then, the largest possible multiple of 11 is 88, which yields 4. Bring down 0. Then, we have 33 as the largest possible multiple. And we have the desired remainder, 7. So, we already have the dividend, 2020, the divisor, 11, and remainder, 7. So, we can now express it into 2020 is congruent to 7, modulo 11. So that is it for today, Mathverse. I hope you enjoyed and learned something from this video. If you did, make sure to give this video a thumbs up as well as subscribing to our official YouTube channel, Cedie's Mathverse. I would also like to remind you to stay safe amidst the COVID-19's outbreak. See you guys out there, and remember, mathematics is incomplete without you.